Python scripting tutorial. Introduction. Python is a programming language that is relatively easy to learn and understand. It is open source and multi-platform and can be used for many purposes, from simple shell scripts to very complex programs. But its widespread use is as a scripting language embedded in other applications. That is how it is used inside FreeCAD. From the Python console or from custom scripts, you can control FreeCAD and make it perform very complex operations. For example, from a Python script, you can create new objects, modify existing objects, modify the 3D representation of those objects, modify the FreeCAD interface. There are several ways to use Python in FreeCAD. From the FreeCAD Python interpreter, where you can issue commands in a command line style interface. From macros, which are a convenient way to quickly add a missing tool to the FreeCAD interface. From external scripts, which can be used to create quite complex solutions, even entire workbenches. In this tutorial, we'll work on a couple of basic examples to get you started, but there is much more documentation about Python scripting available in this wiki. If you're totally new to Python and want to understand how it works, we also have a basic introduction to Python. Before proceeding with Python scripting, go to Edit, Preferences, General, Report View, and check two boxes. Redirect internal Python output to Report View. Redirect internal Python errors to Report View. Then go to View, Panels, and check Report View. Writing Python code. There are two ways to write Python code in FreeCAD. In the Python console, select View, Panels, Python console from the menu, or in the macro editor, select Macro, Macros from the menu. In the console, you write Python commands one by one, executing them by pressing Enter, while macros can contain more complex code made up of several lines, executed only when the macro is executed. In this tutorial, you can use both methods. You can copy-paste each line in the Python console and then press Enter, or copy-paste the entire code in a new macro window. Exploring FreeCAD. Let's start by creating a new empty document. Doc assigned FreeCAD.new document, open paren, close paren. If you type this in the FreeCAD Python console, you will notice that as soon as you type FreeCAD dot, a window pops up, allowing to quickly autocomplete the rest of your line. Even better, each entry in the autocomplete list has a tooltip explaining what it does. This makes it easier to explore the available functionality. Before choosing New Document, have a look at the other options. Now our new document will be created. This is similar to pressing the New button on the toolbar. In fact, most buttons in FreeCAD do nothing more than execute one or more lines of Python code. Even better, you can set an option in Edit, Preferences, Python, Macro to Show Script Commands in Python console. This will print in the console all Python code executed when you press buttons. Very useful for learning how to reproduce actions in Python. Now let's get back to our document and see what we can do with it. Doc. Explore the available options. Usually names that begin with a capital letter are attributes. They contain a value, while names that begin with a lowercase letter are functions, also called methods. They do something. Names that begin with an underscore are usually there for the internal working of the module, and you shouldn't care about them. Let's use one of the methods to add a new object to our document. Box assigned doc.addObject, open paren, double quote, part, colon, box, double quote, comma, double quote, my box, double quote, close paren. Nothing happens. Why? Because FreeCAD is made for the big picture. One day, it will work with hundreds of complex objects, all depending on each other. Making a small change somewhere can have a big impact. You may need to recalculate the whole document, which could take a long time. For that reason, almost no command updates the scene automatically. You must do it manually. Doc.recompute, close paren, open paren. Doc.recompute, open paren, close paren. Now our box appeared. Many of the buttons that add objects in FreeCAD actually do two things: add the object and recompute. If you turned on the Show Script Commands in Python console option above, try adding a sphere with the GUI button. You'll see the two lines of Python code being executed one after the other. Now let's explore the contents of our box. Box. You'll immediately see a couple of very interesting things, such as box.height. This will print the current height of our box. Now let's try to change that. Box.height assigned 5. If you select your box with the mouse, you'll see that in the Property Editor on the Data tab, our Data Height property appears. All properties of a FreeCAD object that appear there, and also on the View tab, more about that later, are directly accessible in Python 2 by their names, like we did with the Data Height property. Try changing the other dimensions of the box. Vectors and placements. Vectors are a very fundamental concept in any 3D application. A vector is a list of three numbers, x, y, and z, describing a point or position in 3D space. Many things can be done with vectors, such as additions, subtractions, projections, and much more. In FreeCAD, vectors work like this. MyVec assigned FreeCAD.vector, open paren 2, 0, 0, close paren. MyVec.x, MyVec.y. Other vec assigned FreeCAD.vector, open paren 0, 3, 0, close paren. SumVec assigned MyVec.add, open paren other vec, close paren. Another common feature of FreeCAD objects is their placement. Each object has a data placement property, which contains the data base position and data orientation of the object. It is easy to manipulate. For example, to move our object, box.placement, box.placement.base, box.placement.base assigned SumVec, other plot assigned FreeCAD.placement, open paren, close paren, box.placement assigned other plot. Now you must understand a couple of important concepts before we get further. App and GUI. FreeCAD has been designed so that it can also be used without its user interface as a command line application. Almost every object in FreeCAD therefore consists of two parts: an object, its geometry component, and a view object, its visual component. When you work in command line mode, the geometry part is present, but the visual part is disabled. To illustrate the concept, let's look at our cube object. The geometric properties of the cube, such as its dimensions, position, etc., are stored in the object, while its visual properties, such as its color, line thickness, etc., are stored in the view object. This corresponds to the Data and View tabs in the property editor. The view object of an object is accessed like this: vo assigned box.viewObject. Now you can also change the properties on the View tab. vo.transparency assigned 80, vo.hide, open paren, close paren, vo.show, open close paren. When you start FreeCAD, the Python console already loads two base modules, FreeCAD and FreeCAD GUI, which can also be accessed by the shortcuts App and GUI. They contain all kinds of generic functionality to work with documents and their objects. To illustrate our concept, see that both FreeCAD and FreeCAD GUI contain an active document attribute, which is the currently opened document. FreeCAD.activeDocument and FreeCAD GUI.activeDocument are not the same object, however. They are the two components of a FreeCAD document, and they contain different attributes and methods. For example, FreeCAD GUI.activeDocument contains ActiveView, which is the currently opened 3D view. Modules. The true power of FreeCAD lies in its faithful modules, with their respective workbenches. The FreeCAD base application is more or less an empty container. Without its modules, it can do little more than create new, empty documents. Each module not only adds new workbenches to the interface, but also new Python commands and new object types. As a result, several different, and even totally incompatible, object types can coexist in the same document. The most important modules in FreeCAD that we'll look at in this tutorial are Part, Mesh, Sketcher, and Draft. Sketcher and Draft both use the Part module to create and handle their geometry, while Mesh is totally independent and handles its own objects. More about that below. You can check all the available base object types for the current document like this: doc.supportedTypes, open close paren. The different FreeCAD modules are not automatically loaded in the Python console. This is to avoid having a slow startup. Modules are loaded only when you need them. So, for example, to explore what's inside the Part module, import part dot. But we'll talk more about the Part module below. Mesh module. Meshes are a very simple kind of 3D object, used for example by SketchUp, Blender, and 3D Studio Max. They're composed of 3D elements, points, also called. They're composed of three elements: points, also called vertices, lines, also called edges, and faces. In many applications, FreeCAD included, faces can have only 3 vertices. Of course, nothing prevents you from having a bigger face made up of several coplanar triangles. Meshes are simple, but because they're simple, you can easily have millions of them in a single document. However, in FreeCAD, they have less use and are mostly there so you can import objects in mesh formats, .stl, .obj, from other applications. The Mesh module was also used extensively as the main test module in the first month of FreeCAD's life. Mesh objects and FreeCAD objects are different things. You can see the FreeCAD object as a container for a mesh object, and as we'll see below, for part objects also. So in order to add a mesh object to FreeCAD, we must first create a FreeCAD object, and a mesh object. Then add the mesh object to the FreeCAD object. Import mesh, mymesh assigned mesh.createSphere, open close paren, mymesh.facets, mymesh.points, meshobj assigned doc.addObject, open paren, double quote, mesh, feature, double quote, comma, double quote, mymesh, double quote, close paren, meshobj.mesh assigned mymesh, doc.recompute, open close paren. This is a standard example that uses the createSphere, open close paren method to create a sphere, but you can also create custom meshes from scratch by defining their vertices and faces. Part module. The part module is the most powerful module in the whole of FreeCAD. It allows you to create and manipulate BREP objects. BREP stands for Boundary Representation. A BREP object is defined by surfaces that enclose and define an inner volume. Unlike meshes, BREP objects can have a wide variety of components from planar faces to very complex NURBS, surfaces. The part module is based on the powerful OpenCascade library, which allows a wide range of complex operations to be performed on those objects, such as Boolean operations, filleting, lofts, etc. The part module works the same way as the mesh module. You create a FreeCAD object, a part object, then add the part object to the FreeCAD object. Import part, myshape assigned part.makesphere, open paren 10, close paren, myshape.volume, myshape.area, shapeobj assigned doc.addObject, open paren double quote part, feature, double quote, comma, double quote, myshape, double quote, close paren, shapeobj.shape assigned myshape, doc.recompute, open close paren. The part module, like the mesh module, also has a shortcut that automatically creates a FreeCAD object and adds a shape to it, so you can shorten the last three lines to part.show, open paren, myshape, close paren. By exploring the contents of myshape, you will notice many interesting subcomponents such as faces, edges, vertices, solids, and shells, and a wide range of geometry operations such as cut, subtraction, common, intersection, or fuse, union. The topological data scripting page explains all that in detail.